Thank you. I had to re-record yesterday's lecture, so I did do that last night and post it. Okay, so our first circuit, we're going to be building an inverting op-amp with a gain of -3. This is our schematic for it. Here was our equation for our inverting op-amp, that V out would equal -RF over R1 times Vn. And that meant our gain, or what we multiply Vn by to get V out, or the ratio of V out over Vn, however you want to think about that to define gain, should be -3. We have to do this with only the values of resistors given in this table. So you might need resistors in series or in parallel. Remember, resistors in series add. In parallel, if I use all the same resistance value, then my equivalent resistance is just divided by my number of resistors that I used. So again, if I use like 2 resistors and each of them are a value of X, then my equivalent for this would be X over 2. If I have 4 resistors, it would be X over 4 if they're all the same value. So that can help with designing what you want RF and R1 to be. This resistor shouldn't matter since it's a safety resistor, and this resistor won't matter because op-amps make a set voltage out no matter what load you attach to them, what extra you attach to them. We are going to play around to see that with different values. Circuit number 2, we're going to have a non-inverting op-amp, and our gain should be about 15. Again, it doesn't have to be exactly that. You can be anywhere 15.4 to 14.6 to 15.4. I'll be more flexible with that one. This one, I would like to actually be 3. There's a pretty easy way to make it 3, so please do that. Okay. At least in theory. My non-inverting op-amp has a voltage in to my non-inverting input. Then my inverting input has my feedback path to my output, an input resistor, and again, a load resistor from V out to ground. This load resistor I don't see anywhere in my equations because my op-amp makes a voltage just based on RF and Rn here. Okay, so my non-inverting amplifier, that voltage that it makes it V out is Vn times 1 plus RF over Rn. So my gain here is 1 plus RF over Rn. This one's non-inverting because my gain's not negative, it's just positive. I didn't invert or flip the sign from my voltage in to my voltage out. So again, this voltage in, we're going to use a 1.5 volt source, which is going to come from just a AA battery, single one. Did 4 AA's before to make 6 volts, we're now doing 6. Again, you can use resistors in series or parallel to get desired RFs, RNs, or R1s, whatever I've called them here. So keep that in mind. But you need to use only values in the table. The key with op-amps is, remember we said while we draw them with just 3 points, our non-inverting input, our inverting input, and our output, right? This is V out. This is V out coming from here. They have to have power for them to actually work. The op-amps we're going to be using is a very common type of op-amp called an LM741. They all get like initial and number names, I think, it just to make electrical engineers sound smarter. It's like a specific brand op-amp if you want to think about it. But you can always Google the type of op-amp and find its schematic. Normally it will also say, like, it's actually printed on the op-amp really tiny though in letters, that it's an LM741. And they look again like little 8-legged spiders. Oh, I should have brought my op-amp out here. I didn't bring it out to show again. We often only think about 3 points: our inverting input, which gets the minus sign to it, our non-inverting input, which gets the positive, and the output that is the other part. But we also have to power our op-amps or they don't work. So this pin, which is called pin 7, is our positive power supply. And this pin, which gets a V minus, he's a little blurry, is our negative power supply. And don't confuse that with, I'll often write, okay, here's my voltage here, it's my voltage at my inverting input. It's not the same as this. I know that's confusing, but it's not the same. The voltage in my inverting input is not the same as the power I'm supplying here. We are going to supply to our negative power supply, this V minus terminal here, negative 15 volts, and we want positive 15 volts to our positive power supply. Okay, so do not confuse them with the inverting and non-inverting inputs. Those are different. But our op-amp won't work, even though we don't see that power supply often when we draw them here. It won't work unless we give it to them. I don't know. Okay, So let's see this in Tinkercad. Here's my breadboard. From my power options, here's power. I just inserted a single double A battery that's 1.5 volts. I hooked it up to my power rails. Always use your power rails appropriately. Let's get ourselves an op amp now. So I'm going to scroll down. I should have brought a mouse to do this too. That would have been very helpful. Make sure again you're on all components. And here's our op amp. He is a 741. That's just the specific type of op amp. There are other ones you can get from him. Now, when I place him, see he has like 8 little legs or 8 little pins. I don't want to place him so that some of the legs are in the same row, because that would make those legs all have the same voltage. And I don't want them to. I want to be able to have different voltages. So I'm going to place him, but then I'm going to rotate, in my case, because I've rotated my breadboard to be vertical so I can read A, B, C, D, E. I'm going to keep rotating him. And he's actually designed in his size to fit across this gap here. Okay, it's a specific size gap that circuit boards are built with, they're standard, so that now these pins, here's my inverting input. Tinkercad's nice, it even like labels them hovering over. In real life, they aren't labeled. You have to like Google the schematic, right? Keep up with that. Here's my non-inverting input. Here's my power supply negative. They're a little clearer. Here's my power supply positive. Here's my output. We're not going to do anything with these pins, offset 2, offset 1, and the not connected pin. Some of the time you might do something with them, but it's rare. Those are the more common. Okay, but he's designed to go across this gap so that I can have a different voltage at like my non-inverting input than my inverting input. If I had them horizontally where these were all in the same row, then these would be the same voltages as my power, and I don't want that. Okay, it's also different voltages over here than he is over here. These are only connected by a group of 5 pins on one side of the gap, not the other. So that's my op amp. He needs power. I like to always do the power first before I do anything else so I don't forget it. Okay. Now it's actually a little harder to power him in Tinkercad, I apologize, than in real life of what we could do in lab, because in real life I have a board that has a positive 15-volt power supply and a negative 15-volt. If you don't have that fancy of a board that has both what's called a dual power supply, a positive and a negative, then you have to make separate power supplies or use different ones, because this one wants both a negative power and a positive power, and they need to match. You can't just give it one or the other. So under instruments, I get my power supply next to like where we find multimeters. These are just DC power supplies. You either specify a voltage or a current. We're going to specify a voltage and say 15 volts. Okay. Then that means out of the red terminal will be 15 volts higher than what's out of the black terminal. Again, positive and negative. So I want my positive here to go in the row that's my positive power. And I'm going to, click places here so that it's a little more maybe user friendly. And I'm going to give it a red because that is the positive from here. It's different than the 1.5 volts here. So don't connect your positive 15 where you want positive 1.5 volts for the end. That's a very different power, right? The negative, though, I need to say that this is 15 volts higher than this. What I'm really comparing that to is not my negative supply, it's just to ground. Otherwise, this isn't 15 volts higher than ground. This one needs to be negative 15 volts or 15 volts lower than ground. So my negative, I do want to hook up to use the same ground, the same negative terminal, as my voltage source in, and that I will use a ground for my op amp circuit. If you don't do that, then they don't have the same comparison point. And again, that 15 volts doesn't mean anything if it's not 15 volts compared to what point. Right? Remember, voltage is like potential energy for that. So that's my positive power supply. That does nothing to get my negative power supply that I want negative 15 volts. For that, I need another power supply. So I make myself another one. In Tinkercad, it's like magic. I just click and place one and they appear. Now it looks like, we'll tell you, it looks like that you could just type in negative 15. But annoyingly, if you do that, Tinkercad doesn't give you an error or any warning, but it doesn't actually make this negative 15. It can't do that correctly from it. So you really have to make this positive 15. If you try to actually measure it like with voltage with the multimeter, it won't make it correctly, annoyingly. You have to make it positive 15, which again means the red terminal is 15 volts higher than the black terminal. If I really need something to be negative 15 volts, then I'm going to attach my negative terminal into this row. That's my negative power, because he's negative 15 volts compared to the red. So that means I want the red to be my comparison point where I'm comparing all my voltages against. So I'm going to wire him back to my ground. He kind of flips from what I did with the other one. I leave him still red and black so I can kind of tell that this was positive 15. But otherwise, I think, for right now, I'm going to move this so I don't kill my op amp. In real life, if you flip up these power supplies or switch them up, you can burn out your op amp or blow it out, and it's really annoying. In Tinkercad, I think it just gives you warnings or it just doesn't work. You're not going to have, things blow up. But see, if I start this simulation, this guy, even though I tried to type him as negative 15 volts, he tries and he can't do it. So you got to be really careful. This one worked, this one doesn't. So he's positive 15. Now when I hook him back, again, this just means that this terminal was 15 volts higher than this one, or this one is 15 volts lower than this one. So he's negative 15 compared. Now if I compare them, both of them can do that. Okay. That's powering my op amp. Questions or concerns on that? Because again, it's a little tricky when you can't make an actual negative voltage. You have to flip the terminals of your voltage to make it negative. Okay, let's look at the rest of our circuit. What did we want to do here? I'm going to, maybe I can zoom out a little bit. Try this. So I'm going to build this circuit up here first. I have my VN, it's my 1.5 volt battery. I want a resistor R1 to then go to my inverting input. Okay, so then from that inverting input, I'm going to have RF go to my voltage out. Then we'll talk about the other resistors. It's easier if I can make this bigger at a time. I'm going to scroll up, find myself a resistor. And I want one resistor that goes from my VN here. I got to rotate it in Tinkercad. Again, in real life, it's a lot easier to adjust the legs of these resistors. They're flexible and bendable. But he needs to go from my positive terminal to where? To my inverting input, which is now the same as anywhere in this row, right? And then I need a resistor also from that inverting input to go to my output, which my output is pin 6, or this one here. They get numbered 1, 2, 3, 4, 5, 6, 7, 8. They go up a number on this side, which is kind of annoying, but again, Tinkercad's nice that you can hover over them and it'll tell you what they are. In real life, you got to look at that schematic and compare it. So I need a wire that really connects my output back to this guy because I can't make him reach. May not even be able to make him reach well in real life to go across the op amp. Oftentimes you do need a little wire for that, but certainly in Tinkercad he's not flexible. He only has a set length. He now goes from my inverting input to where? To my output. What else do I need? I got R1 and RF. I need a resistor from my non-inverting input to ground. My non-inverting input is pin 3. I just know that, so but sorry, this one. I want him to go to ground, so I'm going to rotate him. You could always add a new wire to ground, but if I rotate him, I can get him to fit without a wire, right? He now goes from my non-inverting input back to ground. And where does this resistor need to go? You tell me, this load resistor. On one end needs to be attached to what? And one end needs to be attached to what? am I going to hook up this load resistor? Yeah, good. Like, it goes from V out from ground. And V out is the output of my op amp, right? Out. So if I make one end of him my output, oops, nope, he moved up too high. Right, that was this row. Then the other end needs to go back to ground. And again, in real life, I might need a jumper wire for that as well. Do be careful if you put resistors, even with one end correctly. If you put an end in anywhere else in the op amp pins that you don't want connected, then that's not correct either. Okay, so you need to avoid like putting something in this row down here or putting things in a row that you didn't want to. Okay. Do be careful with that. Now, I don't have the correct values here. RL, I do think starts at 1 kilo ohm, and this resistor starts at 1 kilo ohm, but you need to choose RF and RN to be the values of resistors you want. If you need to make RF, let's say multiple resistors in series, then I could maybe even start with one, and instead of this wire, I could put another resistor, in series with it. What does in series mean? Same current. Go from one to here, then these are connected, and then from here to here, right? So this would be like 2 resistors in series if I do that. You can keep building with 3, or you can go across, however you need to do it, but you do need to check that the equivalent resistance is then in series to make that RF, right? To go from here to my output. Similarly, if you needed this guy to be in series, then maybe you want him to go to another place before he comes down and reaches our inverting input. If I put just another resistor, so let's rotate this one just to see differently. Oops. I'm gonna move my whole thing. If I put this resistor like here and then just connect wires from them, I'm gonna zoom in so maybe you can see that a little better because they are tiny. Other way, with my finger mice. How are these 2 resistors now arranged compared to each other? Yeah, they're in parallel. And they look in parallel even geometrically, but circuits wise parallel, that means same voltage on this side, right? So all connected. Same voltage on this side because I've now run a wire, even though these are. So if you wanted them in parallel, that's okay. If you don't want them in parallel, make sure you're actually hooking them up like in series instead of parallel. Do be very careful with that. Okay, questions or concerns about our first one? Again, you're likely to have either RF or RN be a combination of resistors, not a single one here. And you need to calculate what they should be to be a gain of -3. There are multiple possible answers for how to do this. I don't limit you to just one. You want to then measure the voltage drop across every resistor in your circuit. Okay, so remember, take your multimeter. Somewhere I have a multimeter. Our multimeter, and to measure voltage drop, I can just attach from even directly to the resistor if you want, from one end, like these to be read, to the other. Okay, I do not require you to measure current anymore through each resistor. You can if you want to, but that's more of a pain again to rotate them and make the wires in series. I assume by now we're good enough with Ohm's law that you don't have to do that. If you knew the voltage, you could calculate the current. So just the voltage drops across each resistor are what you're required to measure. Let's look at the rest of this. Okay, so our voltage source will be this. Our load resistor is initially 1 kilo ohm. Explain what resistors you're going to use to make your gains appropriately. Circuit 1, that inverting amp has a gain of -3. For circuit 2, we want it to be about 15. We'll talk about it. And then calculate the theoretical current and voltage drops and power. But in Tinkercad, I do ask you to measure resistance to make sure you're using the resistors that you think you should. Then measure resistance with them not hooked up to their circuit. Don't forget to power your op amp with both positive and negative 15 volts. We talked about it's a little tricky to do that. And measure the resistance of each resistor and the voltage drop. I'm going to actually cut this out and say you don't have to measure current. You can do it if you want, but I won't count off for not doing that here. Okay, for circuit number 1, you need to change the load resistor to a different value. It started at 1 kilo ohm. Choose something between 500 ohms and 5 mega ohms. So if you choose, I think, really high, it gets off from that. In theory, again, I should have the same voltage drop across it, even though I changed its resistance. Because that op amp makes a set voltage out no matter what you attach to it, which says it can make this voltage even if I have something that is a lot of resistance that I'm attaching, or it's using up a lot of electrical energy for me, right? And then you only need to remeasure the voltage drop over that RL. Okay. For circuit number 2, you don't need to change the RL. That's only for circuit 1. Circuit number 2 is going to be our non-inverting amplifier. So here's our non-inverting amplifier. Let's see if we can hook it up like this in Tinkercad. Zoom out. Okay, I'm going to delete my multimeter and all this stuff just so I don't have confusing things. This was my power to them. I'm going to delete my resistors and start from scratch just so I know I don't end up with something I didn't want. The only thing I'm going to leave is my power. This was my positive power. This was my negative power. Need that wire anymore, he's going to nowhere. And positive power is compared to ground. Negative power also compared to ground, just flipped what's red and black. Seems a little weird. Okay, for this one, I want VN to go to my non-inverting input. So how am I going to do that? How am I going to wire that in Tinkercad? Where is VN here? Where do I see VN in the circuit? Where could I hook up something that's attached to VN? Where do I get VN here? Got to be able to interpret what's drawn here versus what am I building in real life, even if it's virtual life. Can you also hear me? I'm now nervous. Okay, thank you, Marcella. The positive power rail. Yeah, the positive power rail has my positive 1.5 volts. This was my VN source compared to ground. So I want my positive power rail to go to where? My non-inverting input. So anywhere in my positive power rail, I'm going to just click to make a wire. And here's my non-inverting input. So anywhere in that row. Please don't run a wire directly to these pins. I know you can do it in Tinkercad. In real life, those pins are taking up a spot and you can't fit multiple wires in the same pin. That's why you get all the pins next to them. So please use a new pin. Oops, now that it's all smushed, it freaks out on me. I just want to change the color. I don't like it being black. It's red. Okay, so I've got that path picked up. Now what do I want to attach to my inverting input? You tell me. What do I need attached to this inverting input? That inverting input is this pin. He's pin 2. Anywhere in this row. So what gets attached to my inverting input here? Good, Marcella. I have one end of RN and one end of RF. So let's get us some resistors. I'm going to make this big now that we're okay with that. Because otherwise I can't see enough of what I'm doing. Hold on. I have to rearrange all my chat windows. Go back up, get a resistor. So one of them, Rn, if you look at that schematic, goes from ground, my negative power rail, to my inverting input, this guy here. Rf has one end in my inverting input. Where do I want to attach the other end of him? Assuming he was a single resistor. Again, for you, he might actually need to be multiple resistors. I'm going to build this just assuming RF could be a single resistor. What do I need to attach up here to the other end of RF? Where do I need to run a wire to? Good, Brandon, the output of my op amp, which is this one here. I like him to be a color since he's not really my positive or negative. I like him to be a different color. You don't have to use a different color. I just like that. You also need, I'm not going to show you this one completely, but that gets me, too many windows. I've got RF, I've got RN. You also need a load resistor here. Okay, he should go from where? From our output. The output pin of our op amp is pin 6 labeled on our, and if we look at this, that's our output. Pin 6, second from the bottom on the right hand side. To ground. Okay, so you need that RL there too to measure that voltage drop across. Now you are going to design this so that your gain is about 15, which you need to choose values for RF and RN that will make about that. And again, it can be anywhere between this. That's okay, but you should be able to get close to that with them. You will need multiple resistors to do that with the limitations of resistors I've given you. So there are multiple possible answers, but choose something with that. Okay. I will warn you, if Vn here is 1.5 volts and I make this gain 15, what in theory do I calculate V out should be? It should be Vn times my gain, right? So what should that be? Yeah, about 22.5. What did we say? Ideally, we could get any voltage out up to infinity in an op amp. But in reality, what is our voltage out limited by in an op amp? Does anyone remember that? What are we really limited by to make a voltage out? So if I take 15 times 1.5, I think I should get 22.5 volts out. I'm just going to tell you, you aren't going to get that. This is the one time where our expectations are not going to meet reality. Why is that? What am I limited by with op amps? We said they're magical and can do math, but they're not perfectly magical. They can only do math up to a certain point. Good, Eric. You're limited by the power you're supplying them. Okay, again, we don't see that here in theory, but we had to power them, right? We had to give them positive 15 volts and negative 15 volts, which means, again, if you were going to try to graph on your x-axis, if you put your voltage in, whatever voltage in you wanted for your whole circuit, and your y-axis, your voltage out, then in theory, if I have something that just says I take V in, I multiply it by 15 to get V out, this should be a line with a slope of 15, right? Take V in, you multiply by 15, you get V out. It looks like y equals 15x. V out equals 15 times x. In reality, though, this slope will only be linear, what we think it should be, up to a point, and that point is what power we supply it. So what are we giving in power to our op amps here? What are we connecting to our positive power supply? V plus here. Good, Miriam, positive 15 volts, which means the op amp is not magical enough to pull out any voltage higher than that. Okay, he's not actually a power supply, he just does math on things. So we can't make a voltage higher than this will flatten out at positive 15 volts. And it'll actually slope up to that point. So even close to that, you won't get 15 volts out. Reaches that as an asymptote. Same with we had to give it a negative power supply. It won't make anything lower, even if you're trying to do an inverting op amp, right? And flip your sign. Won't make anything lower than negative 15 volts. So can I make this positive 22.5 volts that I think? No, big fat no. This is one of the few times I'm setting you up for failure. What you should build in this circuit and in theory calculate is the voltage drop. Like the voltage drop across RL should be, if I measure it positive, negative this way, from V out to ground. It should just equal V out, which I think should be 22.5 volts, but it won't be, okay? I'm just telling you now, this is when you will get a high percentage of error. You still need to calculate it, and then you need to explain why. It's because it can't make a voltage higher than the power you're supplying to that op amp. Because it can't make this voltage here, the voltage drop over RF will even be off because it goes from, what's my voltage right here? It has to be the same as my voltage right here. What's my voltage at like my inverting input? Good, Brianna. It's equal to Vn, which is 1.5 volts, right? This guy's 1.5. This had to be the same if I have a feedback path, which I do. So he goes, the voltage drop over RF goes from 1.5 volts to V out, right? Which is 1.5 to, in theory, 22.5. Be a large negative number. He won't be that either because V out isn't that. Vn even at this point will have trouble because while the voltage drop over Rn thinks it should just be from Vn to ground, really this current had to come from here and then go through here, right? Because it couldn't go up here. If this current is off because V out isn't what you think, then this current is off as well. So he doesn't make the same voltage drop here either. So all of your measured voltage drops for each of these three resistors in the circuit will be off, as in you will have a high percentage error. That's okay. In this case, that's why. And I'm doing this to you so that you learn, oh, okay, I thought I can make it 15. In theory, calculated this. I've done this many times myself, go on with my life. And then I'm like, why am I not getting what I thought out? Oh, because I'm not supplying enough power to my op amp to actually make that. Okay, and it makes everything else wrong. Now, in circuit one, what should I get for V out? This is my inverting op amp. I'm trying to make it with my gain here that was -3. What do I calculate in theory I should get V out here? My Vn is still at 1.5 volts. You got to do your theoretical calculations too. Remember to compare them. What do we think we'll get for V out here? Yeah, good. -4.5, right? I'm just taking -3, that was my gain, multiplying it by my Vn, which was 1.5. And last time I checked, that got me, yeah, -4.5. I don't ever trust myself to do algebra. I put them in a calculator. Can I make that with the power I'm supplying? Do I think I should get close to that voltage for V out for my op amp? It's a yes or no question. Do I think I can make negative 4.5 volts? You have a 50-50 shot if you want to guess. Yeah, I think I can make that. That's between my, again, the limit to my op amp. If I give it positive 15, negative 15, negative 4.5 down is down here. That should be when it is in the about linear range. It's just when it gets to these close to these limits, it won't do that, and it can't ever exceed them. Okay, so for circuit one, your calculated voltage drops compared to in theory, or your measured voltage drops compared to in theory, should be close. Again, the voltage drop over RL goes from V out to ground. V out here should be negative 4.5. What's my voltage right here at my non-inverting input for this circuit? We've done this circuit before, or using our op amp rules. We find that voltage. Well, it'd be nice to think it's 1.5. It's 1.5 on this side, but I have a resistor. Can I have current through this resistor, through R1? Yes, because it doesn't have to be 0. It doesn't have to go in the op amp. He can go up here. So if I can have current, I can have a voltage drop, which means I can change and no longer be at 1.5 volts on this side, which this guy has to be the same voltage as this. What voltage will I be? Will I have current through this resistor, this 1 kilo ohm resistor? Yeah, I'm going to have no current through him, so 0 amps, which means he also has a 0 volt drop, right, delta V. And he started at ground, so if he doesn't change any voltage or he dropped no voltage, my voltage here will be 0 volts. If I have feedback paths, the voltage at one input has to be the same as the other. He's also 0 volts. So different than when I was here. Again, got to analyze each op amp circuit differently or separately. They can have different hookups, right? So R1, the voltage drop over R1 goes from what voltage to what voltage? I say from here to here. From Vn to 0, right? And our Vn is 1.5 volts. RF goes from 0 volts to V out, okay? So again, we drive those circuits, just make sure you remember how to do them when you're doing your theoretical calculations. When you measure these voltage drops, they should be close for circuit one. Circuit two, though, is going to be a big pile of lies and not be close. Questions or concerns about anything for this? That's the end of describing lab that I have. Again, you need to build both those circuits, measure all the voltages. I'm not making you measure all the currents unless you just want to. The current in circuit two will be screwed up as well if you do that, but you need to compare them to the theoretical voltage drops across those. And then you do need to also measure with RL for circuit one changed, just to prove that it will make the same V out no matter what RL was. Okay. In your discussion, you'll need to talk about what you learned about op amps, why are op amps useful, why do we use them for things, and do your measurements for your circuits match your expectations? This is a specific one I'm telling you in circuit two, they will not. Why won't they? I don't care if you calculate current then or not. In theory, some people find it easier to calculate current because that's what you're doing with nodal and then do voltage drops. But really all I want is the voltage drops, so you're comparing that. That makes you nervous and you want to practice in measuring that, because on the test, as a hint, I can ask you to calculate current at a point in an op amp circuit. So if you want to go ahead and get practice with doing that, go for it, but I won't require it for this lab since you're only measuring the voltage drops. Okay, if we don't have anything else or any other general questions, we are going to Kahoot. This is a longer Kahoot, but I'll tell you a lot of the questions are stuff I already asked before. We're just reviewing kind of everything for our test for that, but please let me know if there are questions beforehand. Again, hooking up that, I'm gonna try to close things I don't want, which is really annoying when I didn't bring my actual mouse pad. Be very careful hooking up your power supplies for your op amp. That's the hardest thing. Positive 15 volts compared to ground for your positive power supply is pretty easy, but negative 15 volts, you really had to flip the terminals, since this one would be 15 volts lower than the red one. I attach red to ground, which seems weird, and then the black one to my negative supply. Okay. Ready to Kahoot? Are we all excited? If you want to go to kahoot.it, enter a game pin. Again, please use your 6+2 so I can keep track of them. I like the excitement. Marcella, thanks. Oh, Mary, I'm sorry, I didn't even read the name. Make sure you have a calculator and some at least little piece of paper. These shouldn't be long calculations. The longest I give you is I think 2 minutes or 1 minute and 30 seconds. But if you don't have even just a calculator, having your notes for your op amps, for Thevenin, Norton, any of that notes or the handout of equations might be good to have before we get started. Give you a minute or two to get that ready. Again, the points don't matter for this, so it's okay if you aren't, but it does make it easier if you have your notes that you can reference. Give everyone another minute to pull those up if you want. Please remember the test, you need to show work and you will need to be submitting your work after your test answers. So for when you need the test answers, I won't accept a final answer if you hadn't put it in the test in that time limit. I will accept partial work from it, and your work needs to match that answer. So you'll be submitting your answers in the time limit, but then uploading either pictures or scanned version of your work or computer written work, however you want to do it. It needs to be legible so I can read and grade your work. If you put in the right answer and don't have work for it, you will not get credit. If it's a fill in the response one, at least. Okay. Anyone still need more time? And I will be on WebEx during the test if you have questions. It's better than staring at one and being like, I don't know what she's asking for forever. Normally I can give you a little hint of getting started, so do ask if you want during it. And again, please come see me and Lucy on Thursday if you're around Cincinnati and want to, or virtual office hours on Friday, or both if you want to do both. And come with questions or problems. Okay, we're going to go ahead and get started. Elements in series have the same what, while elements in parallel have the same what. It's up here. Good. Series means has the same current. Parallel means have the same voltage. It does not mean that they're just geometrically parallel. They can be parallel arranged and look like this, look like a 90-degree angle and just have a wire connecting. It goes from the same voltage on one side to the same voltage on the other side. Make sure you can identify elements in series or parallel and what they mean. Tadwalra is in the lead, followed by Hester P.S. Question 2. If the voltage drop across the resistor increases, what happens to the current through the resistor? Good, it increases as well with Ohm's law. Make sure you are comfortable with Ohm's law forward and backward. I know you don't have to memorize it, but it is helpful. Make sure you know that it is the voltage drop, which direction with current across the resistor, and how it plays in a role with power, plugging in our power equations. Those are all things that can ask relationships like this between resistance, current, voltage, power, all that good stuff. Hester PS is now in the lead, followed by Homans JE. Question 3, true or false? The power dissipated by a resistor is linear proportional to the voltage drop across that resistor. Means if I double one, I'll double the other. That's what linearly proportional means. Ooh, we got almost an even split. So, pull up something. Can I draw? Go back. Put my little drawing pen. We have power equals current times voltage, which looks like if I increase voltage, I increase power. Like if I double voltage, I double power. But if I double the voltage drop across a resistor, do I change the current across through a resistor, flowing through a resistor as well? The answer is yes, these are tied. So our other power equations, if we plugged in Ohm's law for either current or voltage, we get power equals voltage squared over resistance. That I can see R stays the same. What happens when you change V to P? Or current squared times resistance. So do be careful with that. It looks linear here, but that's only linear if this stayed constant, and it doesn't. For a resistor, if you change voltage, we just said you change current as well. King 3A7 is in the lead, followed by Mora. We had a shakeup in the last one. So, question 4, what is the Thevenin equivalent voltage of the following circuit? Ooh, almost even split here. Here's my circuit. How do I find the Thevenin equivalent voltage? It's the open circuit voltage between A and B. With this open, as in assuming nothing else is going to be attached between A and B, what's the voltage drop across R2? If A and B is left open, what's the voltage drop across R2? Good. 0 volts, because it has no current that can go through it. It has no path. So it's like a wire, as in I didn't change voltage going from here to here. No change in voltage. Go all the way around, and I can see I'm 1 volt compared to B here. Or what's the voltage drop over R1? Also 1 volt if you chose to go this way, right? They're in parallel. So the fact that this is open when I do Thevenin equivalent is why that voltage drop is 1 volt. I don't lose half of my voltage over one and half the other. They aren't in series. Even if I were to attach this with a wire, they'd then be in parallel. So gotta be careful with that. Sulliv CG is now in the lead, followed by Walter E3. Question 5, what is the Norton equivalent current of the following circuit? How do we do Norton current instead of Thevenin voltage? Do we like Kahoots in general? Do we feel like they help? I wish I could make the music so y'all could hear it while you do it too. Music is really what makes Kahoots. Ooh, most people did not get that one. Okay. How do we find the Norton equivalent current for a two-terminal circuit? Thevenin equivalent voltage, we said, was the open circuit voltage. Looking for the voltage between A and B. What do I do for Norton equivalent current? Do I leave it as an open circuit? Or what do I do? Good, Miriam. I short circuit between A and B. So now what is this going to look like? I'm going to redraw it. Okay, so now I have 1 amp. I still had my 100 ohm. I have a 200 ohm here. And I had A and B. What is a short circuit? What does that mean to make a short circuit between A and B? What am I drawing between A and B? Good, a wire. And I'm looking for the current that goes in that wire from A to B. Like when I did Thevenin voltage, I was looking for the voltage at A positive to B. Do keep in mind the sign for that can matter. So I want to know that current. How can I find that current that goes from A to B? That will be my Norton equivalent current. Well, I have a current here. How are these two resistors now related to each other? I'm going to erase this. He's not a current source. I'm just looking for the current that flows in that wire. How are the 200 ohm and the 100 ohm now related to each other, those resistors? Good, they're in parallel. Again, they don't look geometrically in parallel, but circuits-wise parallel, right? Means have the same voltage drop. On one side, they're connected at the same point. The other side, now that this is wire, is the same point. If I have two resistors in parallel, what was our shortcut for finding the current through one of them? Remember when we had two resistors in series, we could have a shortcut for finding the voltage drop across one of them. That was called our voltage divider equation. What's our shortcut here when we have resistors in parallel? They'd obviously have the same voltage drop, but how could I find their currents? Good, current divider. That one you probably don't memorize, that one you probably look, but make sure you know which ones you're finding for. Current divider says the current, like through one, would equal I total times your current through the other, if you have two branches, over R1 plus R2. So in my case, if I want this current, I'm going to call it I Norton. What's my I total here? One amp, because that 1 amp is before it would split to either go through here or go through here back, right? So I have 1 amp. Oh, and this isn't I2, sorry, this would be R2 if I'm finding the current through I1. So which resistor am I going to put here in my equation based on this circuit? I want the current that goes through this part. And what resistor do I put here? So the current through this one is the current through my 200 ohm guy, right? It'd be coming from here and then come down. What I want is if you're calculating I1, it's the opposite branch's resistance. So I don't want this branch's resistance, which was 200. I want the opposite branch, which is 100, over the sum of my resistances. That's not their equivalent resistance. It really is just their sum, which in my case is 100 plus 200. So current divider is trickier than voltage divider. They look very similar in setup, but it's the opposite branch's resistance here, not the one you're actually looking for the current to. Be very careful with that. So what does that get me? I have 100 over 300, which is 1 over 3, is 0.33. Questions on that? Because most people did not get that correct. If I had wanted the current through the 100 ohm, then I would be plugging in 200 in this value instead. But opposite branches resistance. Okay. Luby, CN in the lead, followed by Sulliv, CG, and then Jolly, GT. I can't say things today. Question 6. What is the nodal analysis equation for node V1 according to the arrow directions? So here's V1. This arrow is going to the right. This is 10 volt source, 1 ohms, 2 ohms. This arrow is going down, 3 ohms and 4 ohms, and this arrow is going to the right. Right, down, right. Five seconds left. 3, 2, 1. Okay, most people at least get this one. So this current, when I do nodal analysis, I look at current entering equals current leaving. This one's entering, these two are leaving based on my arrows. I have to write them as a change in voltage over resistance, again, based on the arrow direction. This one starts at 10 volts, goes to V1, so 10 minus V1 over 1 ohm, which is just 1. This one goes, then equals this current plus this current. So this current is V1 to ground, V1 minus 0 over 2, V1 minus 2. And this one I can go all the way to ground if I realize these are in series. So the current through one had to go through the other. Be V1 all the way to ground, V1 minus 0 over 3 plus 4, which is 7. We've seen that one before. It's just a review to remind us. Sullivan, CG in the lead, followed by Hester, PS. Question 7. What is the current IX in terms of mesh currents I1, 2, and 3? IX is going down. I1, 2, and 3 are all clockwise. Here's I1, I2, I3. IX down through this resistor R1. If I could find my mesh currents I1, 2, and 3, then what did they mean in terms of actually knowing the current through R1 here, IX, if I had to find them going down? Again, I like to always define my currents clockwise. You don't have to, but it makes it easier with the sign convention to then core brain should always be positive for one mesh, just current, and negative for any overlapping meshes. Good. He would be I1 would be going down, so the same direction as IX, hence positive I1. I2 would be going up, so the wrong direction, so we get to negative. I1 minus I2. These are the two meshes that overlap here. So don't forget, when you solve for mesh currents, you need to be able to go back and plug in for what did that actually mean for the individual currents through each resistor and their individual voltage drops. You know one, you know the other. Sullivan, CG, Stone lead, followed by Hester. Question 8. What is the power absorbed by resistor R2? I think this is the last of our review ones, and then we'll get into the op-amp ones that are new. Here's R2, he's 5 ohms, this is 5 ohms, this is 10 volts. You can't see that well. 5 ohms, 10 volts. And you got time, you got 72 seconds, so. If you've already submitted an answer and you haven't got out as the morning, I think the last two are op amps. Make sure you have your op amp notes for that out. Good. So I can use voltage divider here if I don't even want to calculate the current first. And again, I encourage you to use it. It will save you time. They're both in series. So my voltage divider would be my total 10 volts times, if I want the voltage drop over this guy, he's 5 ohms over 5 plus 5. Or I can know that they're identical resistance. So I'll get half my voltage drop here, half of it here. So half of 10 volts is 5 volts, either way. My power is then V squared, so 5 volts squared over R over 5. That's 5 squared over 5 just gets me 5 watts. You could have calculated the current, says 10 volts over 10 ohms in total. It's 1 amp. 1 amp squared times resistance would get you the same, or current times resistance. But I encourage you to, again, use voltage divider when you can if you want to. Sullivan CG is in the lead, followed by Hester PS. What is V out for the following op amp? We have a 1 volt source here, a 2 volt source here, 1 kilo ohm for my inverting input, 5 kilo ohm from inverting to output, 2 kilo ohms to my non-inverting input, 10 kilo ohms to ground. Okay, almost even split here. What type of op amp was this? As a hint, he was one of our 4 general op amp circuits. Any ideas what type he was? Yeah, mixed answers between inverting and non-inverting. Well, I have a voltage source that goes in my inverting input, but my non-inverting input, if he's an inverting input, would just need a resistor to ground. I've got a voltage source here and resistors that I could have current. That's not the same. Good, Leah. He's actually a difference op amp, the one we learned yesterday. I have 2 voltage sources, and then through resistors, they connect to each input, my non-inverting and my inverting. So that was step 1, if I can do that. Or I can use my general op amp rules, but it's a lot harder for this one. This can have current going this way. This one can have current going this way. Okay. If I find my voltage at this midpoint here, then it has to be the same voltage here. I can find that by voltage divider because these two would be in series. No current here. Find the voltage here and then find V out, but he's kind of a giant pain in the butt to do that. If I don't want to do that, I use my general difference amplifier equation that says he's VB minus VA. VB is what's attached through a resistor then to my non-inverting input. That's 2 volts. This is VA attached through a resistor to my inverting input. So 2 volts minus 1 volt gets me 1 volt. He multiplies by the ratio of my resistors as long as they're the same. 5K over 1K gets me 5. 10K over 2K gets me also 5. They are the same even though they aren't the same value. So I get 1 volt times 5 is 5 volts. If you found the voltage at this midpoint, that's longer. Again, not using our set op amp, but I could use that with voltage divider. He'd be 2 volts times, I want the voltage drop across this 10 kilo ohm. So it'd be 2 times 10 divided by my total is 12, 10 plus 2 kilo ohms. That means my voltage right here is 5/3, or in real numbers, 1.667. That means this voltage is 1.667 volts. And he goes from 1.667 volts to V out. He goes from 1 to 1.667, which actually means my current's going the other way, which is why I have a higher voltage here. From it, I could find that current, and he'd be the same here. That current will be 1.667 minus 1 volt. So minus 1 gets me 0.667 over a kilo ohm. So divided by 1,000 gets me 0.000667. And that current times 5 kilo ohms gets me the voltage drop here, which is from V out to this point. I have to add back 1.667 to calculate V out from him, which I think I've rounded. What did I do wrong from that? Did something wrong from that. 1.667, that makes sense here. To 1 over 1 kilo ohm. Oh, because I just multiplied them by 5, not 5,000. I was like, that looks really small. Why my units matter. Oops. Still can't add, sorry. Typing things in my calculator. 5,000, not 50,000. That plus 1.667 gets me that the voltage drop over this guy was 3.33 volts. That means he goes from V out to that point, it gets me 5. Is it different only if there's a voltage source to both inputs? Technically, you could have really fancy ways that you're hooking up these, like, you know, if I have parallel resistors or something like that. Even though I have 2 voltage sources, there are other ways you could hook them up. So you do have to be careful to match the rest of the hookup for them. Again, if I have a resistor from V out to ground here, that won't change anything, but changing the rest of these resistors can. So you do need to be careful with that. It's not necessarily a difference amp just because I have a voltage source to both. Okay, sorry, that took me longer of typing in my calculator than I thought. Hester PS is in the lead, followed by Sullivan CG. Last question. What is the gain of this op amp? Remember, how do we define gain? Oh, equal split. What type of op amp is this one? Equal split ones always are more interesting to me when people are 50-50 divided on what they thought the answer was. Yeah, he's non-inverting. I have a voltage source to my non-inverting input, and then my inverting input just has a resistor to ground and a resistor to my output, a feedback path. What is the equation for non-inverting amplifier's gain? How do I calculate the gain for that? Good, 1 plus RF over RN, where this is RF and this is RN. So what's RF over RN? 3 kilo ohm over 1 kilo ohm gets me 3. I gotta add 1 to it, don't forget that. So 3 plus 1 gets me 4. Third place, Hester PS, congratulations. Second place, silver medal, King 3A7, congrats. And gold place, they make this very dramatic with the spotlight, Solo CG. So thank you all for playing. Again, hopefully that gives you an idea of the more simple or faster questions that I would expect you to be able to answer. Again, please be doing book problems because they can be longer and more complex, particularly for your free response ones. If you have any questions or things for lab or problems or your test, I'm happy to answer them now. That's all I have. For the lab, you can meet in your group projects. If you want to be working on that, do keep in mind they're due coming up pretty soon in July. Crazy, we're about to be July. So you can take the time to do that. If you have questions, let me know. Have a good one. Otherwise, hope to see you at some form of office hours. Your appendix should always be your measurements, just so, because that's going to be just a ton of images and labeling them. So yeah, you should always have an appendix section that are just the measurements of your voltage drops or currents if you're measuring those two in that lab. I forgot whether I required measuring current. I think I did for that one. For this coming week's lab with the op amps, as once I said, you only needed to measure voltage drops, but they should be in your appendix from that. Otherwise, you have a whole bunch of screenshots of each of your measurements that take up a whole bunch of length in the middle of it. Leah or Maricela, questions I can answer?
So with power, we only need to calculate it with the theoretical values, right? Like not with the measured values.
Yep, and we don't measure power either. There's no like actual power measurement, which is kind of weird. It's either measured voltage or current and then plugged in, or resistance and plugged in with that. So yep, I only need theoretical power.
Okay.
There's no power setting, as you can see on your multimeter, to compare it to either, so that's why.
Yeah. Okay, and then with measuring the current through the resistors, if we used like multiple resistors that have the same resistance in parallel,
You only need to measure one of their currents. That's okay if they have the same resistance.
Okay.
It's just if you had different resistors in parallel, then they would have different currents, right?
Yeah. Okay. That was it. Thank you.
Yep. Leah, any questions?